Welcome to Aaron's Particle Space. In this video I'm going to introduce a new feature called particle signaling. This is where you can send signals through particles in a rigid body or a particle field, and those signals can trigger reactions in other particles. So this allows you to do wiring circuits or just triggering events. So to do that, it's pretty straightforward. I've taken a fairly, what I think is a unique approach to signaling. There's really only a couple of settings that you can do a lot of things with. So first up, we need to create a particle that we can signal. So we'll click on creation, go to the Devlog group, we'll add a new element, and we'll call this wire, because this will be the main particle that we use to transmit signals. And to make a particle able to pass on signals, you need to go into its properties and go to the conductive setting. And here all you need to do is just set it to a value of 1. And that means it's now ready to pass on signals. Pretty straightforward. So if we draw a line of particles like this, and we'll just pin that to the background. Right, we now have a piece of wire. Of course, the problem is we don't have any signals yet, so we'll need to go back to our group, add a new element, and we'll call this battery, just because it's a cool name. And in the properties, again, we need to say this will be conductive. But we're also going to do one other thing, and that is in the reaction section we're going to add a new reaction which we'll call power, and the new option here is called generate signal. So what happens is when this is 0, no signal is generated for the reaction, but when we enter a non-zero value, like a lot of the other options here, it will generate a signal in that number of seconds from now. So if I go 1, it basically means it will generate a signal essentially every second. So if we would draw a battery, it should now be pulsing, which doesn't appear to be. Of course, because we haven't set the reaction type. Okay, so in this case we want the battery to be running all the time, so I'm just going to make this an always reaction, and so now our battery starts pulsing. And if we take it and touch it against our wire here, you'll see the signal travels through the wire. And basically we can do anything with this wire. We can add more bits to it, and again you'll see the signal propagates through. Now what we can do is, in the properties we can say it's conductive, but we can also, we have another option down here, collide/signals with all particles. So what I'm going to do is create a particle that only collides with wire, signals with wire. And we can transform, say, that one. Yeah, so if we hit that now, as we can see the particle, as we'd expect, the signal runs through nicely. Now this is where things get interesting. We go back, and now I'll create a new element, and I'm going to call this logic. We'll call this gate 2, and like gate we're going to make it conductive, and we're also going to have it that it only collides with a gate particle. Okay, so I think this is where things get interesting now. So if we transform this particle here into a gate 2, what we've basically got now is we've got the wire particle, which is conductive and can pass signals into any particle, so the gate 2 will pick up a signal. And we have the gate 2 particle, which can only pass signals onto the gate. So if it gets signal, it will pass the signal on, but it won't pass it onto wire. It will only pass it onto another gate particle. And then the gate particle only passes its signal. Oops. Only passes its signal onto wire. So what happens is, if you've worked it out already, is our signal passes through wire to gate onto wire. But if we come this way, our signal dies. That's because wire will pass it on to the gate signal, but gate only passes onto wire. So this gate 2's in the way. He's not going to pass signal on. He'll try and pass it back, but he can't because the signals come from there. So effectively the signal stops. So to those who know anything about electronics, it's sort of a bit like a diode. Energy, or the signal, can only run in one direction, not in the reverse direction. Alright, so what does that mean? Well, it means we can do some interesting things. If we were to draw another line off from our gate 2 particle, what do you think will happen? Well, pretty much the same thing. When we touch it, the signal runs through, and as you'd expect, it only goes in one direction because the gate 2 does not go back on the other wire. It only goes to the gate and it runs forward. So our signal now runs that way, and if we touch this one, our signal still runs straight through. So for those who know a bit about Boolean logic, you will probably recognize this as an OR gate. Okay, when the signals, and what we'll do actually, just to make things a bit more interesting, we'll go to battery, and under reactions for power, instead of making it, we're going to generate a really fast signal. So this basically keeps the power on all the time. So now when I touch it, okay, we stay lit up. So yeah, so what we've got is an OR gate. Either one or the other will generate an output at the other end. So pin 1 or pin 2 creates an output. So that's pretty cool. We now have an OR gate. Right, things get even more interesting, because if we come back to the gate 2 and we come back to properties, conductive can actually hold not just the value 1, but you can actually assign any whole integer here that you like. And in this case, if we set it to 2. So what does that mean? So that means that the particle now needs to have 2 signals simultaneously before it conducts. Right. So you can probably guess what that's going to mean. So if I put the signal on here, the gate 2 particle now is no longer conducting because it still needs one more signal before it will conduct. So what we'll do is draw another battery and pop that on, and there you go. Whoops, we'll just pin you down. Okay, and there you go. We now have an AND gate because both inputs 1 and 2 need to have a signal before we get an output. We'll just disconnect that. And so now we have an AND gate. Alright, there's still another option I'd like to talk about, and that's this new option below conductive called exclusive input. And what that means, up until now, the input is 1 or more. So if I touch both, I'll come back here. So if I change this conductive to 1, it comes through, but I can also touch it with this and the same thing happens. Yeah, either of those will keep the input live because it only needs 1 or more. But if we go to exclusive input and change that to yes, you'll notice something interesting happens. The output suddenly ends, and that's because with exclusive input it means that the conductive now has to be exactly 1. So if I take this away, we now get output, no input, input, there's only one input, go to 2, it goes out. And for those of you who are also thinking in terms of logic, you'll now realize that what we've created is a NOT, so that when I apply an input on here, the input goes out over here, and likewise when I have no input, the input gets turned on. So this is now a NOT logic. That's it for now. In the next video I'll show a few more interesting things we can do with particle signaling. Thanks for watching, and see you next time.